it's 5 p.m. I would like to officially kind of introduce our speaker of today. Thanks to everybody joining us, and we have every term when we have this online public lecture series, we have a renowned guest speaker, international guest speaker, and this year it's Michaela Zint from the University of Michigan. And due to the topic of sustainability, I would have liked her to have her own premise, but she said, okay, it's perhaps awkward to fly in just for the presentation. So we will have this online presentation, and we're just in the prologue of this lecture. She kind of told me that she will be here in summer, so it might be that you get an invitation to a presentation during summertime, and then we have Michaela on premise in person. I'm very much delighted that Michaela agreed to provide her background. You know, we all, in fact, who are doing this public lecture series, we are doing it because we have our personal kind of attention to the topic. Yeah, we say we have to do something about it, but in fact, we are not really doing it on a very broad scientific, most of us, some of us, but most of us are having other scientific topics, but they are nevertheless looking also into this area of sustainability. Michaela is from a school of environmental and sustainability research. So she is really in the topic of educating for sustainability. And so I'm very much grateful to have Michaela today as a guest speaker. Michaela, it's your floor. Thank you for
that. Well, thank you. And Gerti, based on what you just said, you know, I remember a time when in the 1990s, as late as the 1990s, when the only people who talked about sustainability were the sustainability schools, you know, students who studied these topics. And nobody else talked about it, and nobody else. And people would frankly say, like, I talked to businesses and, you know, psychologists and engineers, well, except for the environmental engineers. And, you know, and everybody would sort of say, what does that have to do with what I do? And, you know, it's frustrating, of course, for those of us in the field that the change is so slow, because it needs to be faster given the challenges that we have. But it is also exciting to see. It's exciting to see pretty much everybody starting to talk about it. And the talking is kind of the first step. So I want to give you great credit for your your lecture series, because without talking, no change. So the first steps are happening, and it does take these conversations to ultimately bring about change. So it's actually exciting to see. Anyway, so with that, I'm going to formally start my talk. I have my remarks are in written form to keep me on track in time, but I will make them as engaging as I can, and I hope that you will be engaged by them and you will get some food for thought around education and specifically sustainability education in computer science. So with that, I'm going to start let me share my screen, my slide. There you go. And we're set, right? You're seeing it? Okay. Let me adjust something here on my screen. Okay. So today, I want to explore the relationship between sustainability and computer science, not as separate domains, but as deeply intertwined socio-technical systems. Across many technical universities and regions, computing is increasingly recognized as both a driver of climate and sustainability challenges and one of the most powerful tool sets we may have available for addressing them. I'm speaking today, as Gerti said, from the University of Michigan. Michigan is a state in the US that's roughly 3 times the size of Austria. And you can see it is surrounded by the largest body of fresh water in the globe, the Great Lakes. These conditions are actively attracting data centers and AI infrastructure, with more than 60 data centers already operating and multiple hyperscale facilities proposed because of these advantages like water, land, and energy access. Michigan is one example of how local contexts shape where and how computing infrastructures expand, and why sustainability questions are no longer to be treated as external to computer science. Before diving in, I also want to briefly acknowledge the political context I'm speaking from. In the United States, climate and science policy and higher education itself are under increasing pressure, though this direction is far from universally supported. So I want to say recent polls show 40% support for Trump, which is still amazing to me, but it is not, higher than that, at least. So I also want to emphasize at the outset that many of you may already be doing much of what I'll describe today. My goal is not to prescribe solutions, but to surface patterns, language, and frameworks, and to learn from what is already working in your own contexts. Even under institutional constraints, the design of curricula, competencies, and professional norms still shapes what future computing professionals come to see as legitimate, rigorous, and responsible work. One framing that is increasingly used, and I'm hearing it consistently, is that now all jobs are climate or sustainability jobs, including those in computer science. Yet, at least one study has shown that many computer science students are not even aware of the Sustainable Development Goals, despite the scale of the impact their work can have. Computing shapes energy demand, infrastructure expansion, material extraction, governance systems, and social behavior, even as it enables climate modeling, optimization, and decision support. So when I refer to sustainability, I don't mean a checklist of goals, but the challenge of operating within interconnected ecological, economic, and social systems where limits, feedbacks, and trade-offs matter. From this perspective, sustainability is not an add-on to computer science education. It is a systems problem that computing is uniquely positioned to either exacerbate or to help address. Let me be clear that I am not a computer scientist, so giving this talk was a little bit intimidating. My research focuses on how we educate students to become, at minimum, sustainable and climate literate, and ideally sustainability leaders in their professions and communities. I became deeply interested, however, in computer science education because of the rapid rise of AI. If you look at the bottom right figure, you can see just how much more rapidly AI is being adopted than personal computer adoption of the internet. Moreover, as the other two slides show, AI uses and the data centers needed to support it and other aspects of computing, the energy demand is rising incredibly fast. So while AI is an extraordinary tool of innovation and problem solving, the energy and infrastructure demanded to power AI and large-scale computing raise critical questions about how we prepare future computing professionals to engage responsibly with these trade-offs. The Austrian examples from your sustainability lecture series illustrate how computing can shape sustainability outcomes in promising and problematic ways. From energy-aware systems to sensor networks, they highlight the power of computing tools, while also embedding assumptions about efficiency, scale, and control then can carry unintended consequences. Many of you already use, I suspect, these kinds of examples in your teaching. What research suggests, however, is that often missing is treating these cases as explicit learning opportunities for systems reasoning rather than primarily as technical applications. At the University of Michigan, we see comparable patterns. Work by faculty at our institution also illustrates computing's dual role in sustainability as a solutions enabler, particularly through AI, and as a growing problem driver when energy use, infrastructure expansion, and social impacts are insufficiently addressed. The educational opportunity lies in ensuring that students recognize this duality, learning to articulate not only technical prowess, but also trade-offs, values, and longer-term societal implications embedded in their design choices. The graphic on this slide shows a clear increase in research interest in sustainability within computing education over the past decade. This is the kind of thing I'm talking about. It's wonderful to see this kind of interest, suggesting growing recognition that this topic matters. At the same time, this particular study, which was a review of 88 prior studies, finds that most educational responses focus on incremental changes, such as adding modules or examples, rather than truly rethinking the broader purpose of computing education. Much of this work frames education primarily as workforce training, not preparation for what we need, societal transformation. Importantly, this does not mean that faculty, you all, are not doing anything. Rather, much of what is already happening remains implicit, uneven, or under-addressed, which makes it difficult to see, value, and scale particularly effective approaches. The earlier examples from Austria and from my own university show that sustainability relevant content is already present in much computing education, but it is, from what I can tell, rarely made explicit as a learning goal. One reason is that we often start by adding content rather than clarifying outcomes. Backward design, an unfortunate name in some ways in education, flips that logic by asking what we want students to be able to do, justify, and take responsibility for as computing professionals. From there, assessment and pedagogy should follow. And even a simple program-level diagnostic often reveals that many key competencies are already being taught. They're just not named, aligned, or assessed. Don't worry when you see this slide, I'll go through it. This is a sustainability competencies framework that offers a shared language for learning outcomes that extend beyond technical knowledge. It is one I helped co-author with sustainability education leaders from across the world. These competencies, systems thinking, anticipatory thinking, values reasoning, and others, are not add-ons or soft skills. I really think that's a misnomer. I think many times these so-called soft skills are much harder than the so-called hard skills. Anyways, but they form professional, they're essential for professional judgment in working in complex, high-impact systems like the ones we have to deal with in sustainability and in computing science. Many computer science programs already cultivate elements of these competencies through existing courses and projects. The value in the framework is that it makes those outcomes visible, intentional, and accessible. In the next section, I'll walk you through each one of these competencies using concrete examples of learning outcomes, assessments, and pedagogies. Let me start with systems thinking. Systems thinking in computing means understanding algorithms and infrastructure as part of interconnected socio-technical and ecological systems, if we're thinking within the context of sustainability. A learning outcome might be that students can map the system-level impacts of large language models, including energy sources, cooling water, and downstream demand. Assessment could take the form of a systems impact brief or a visual impact or a visual systems map. The key shift is making this integration explicit, asking students to connect technical, environmental, and social, including justice dimensions, and assessing that integration as part of rigorous computing work. Future or anticipatory thinking focuses on how today's computing choices shape possible, probable, and desirable futures under uncertainty. I included the cartoon on the right because in my experience, and I'd be curious if it's the same with you, current students struggle to imagine positive futures, especially when their education emphasizes negative environmental and equity impacts. In AI and data center contexts, students might analyze alternative futures implied by different design decisions, with assessments taking the form of a scenario manual. Guided scenario building and peer critique help students recognize that these negative futures that they're worried about are not inevitable and can be shaped through their cumulative technical choices. Values or normative thinking. This is not about telling students which values are correct, but about making visible which values already shape technical decisions and which ought to be considered. Computing design, as you know, is never value neutral. Choices are being made about efficiency, scale, speed, or equity. They're always embedded. One learning outcome might be that students can justify design decisions in relation to stated sustainability values, with assessment focused on clarity and transparency of trade-offs rather than a single right answer, because of course there isn't one. Role-playing exercises make competing values and sustainability tensions very tangible in my experience. Moving on to strategic thinking. Sustainability challenges are extraordinarily complex. They cannot be addressed by any one discipline or actor alone. This image illustrates the breadth of collaboration, the one down in the bottom, illustrates the breadth of collaboration required across computing, ecology, policy, and practice. Living lab experiences, I don't know if you all use that term, I'm happy to address it more. Living lab experiences place students in sustained collaboration with facility staff, sustainability officers, administrators, and community partners. A learning outcome is that students can communicate across roles and negotiated priorities, with assessment drawing on peer evaluations and stakeholder feedback. In my own experience, working with a class on a sustainability challenge on campus, I have found that if we work on one problem together as a class, it creates a real interdependence and makes collaboration both unavoidable and ultimately very successful. So here, this is about interpersonal. So previously was strategic competence, which is the idea of helping students, preparing students to work on real world problems together to facilitate their collaboration skills, learn the kinds of challenges they will encounter when they're trying to address sustainability. Here, I want to address interpersonal competence, which is the ability to actually collaborate in multidisciplinary settings, because sustainability will only be addressed if you can work with people across many different disciplines. So this particular slide comes from Carla Gomez from a talk as early as 2011 about her Institute for Computational Sustainability. And what you can see here is the vast circle of disciplines represented in her work. And so one of the things that if we get students engaged in interdisciplinary work on campus to try to solve sustainability challenges as they relate to computing on campus, they will likely have to work with students and faculty from different units and departments, which will allow them to better collaborate in the future with these different individuals. Because they'll be better prepared to understand their language, their assumptions, etc., which is necessary to solve these complex problems we face today. So this next one is intrapersonal competence. And this one is about reflecting on your own role, values, and emotions and responsibilities as a computing professional. And I don't know what the situation is with you, but at our university, and certainly also global studies, suggest that many students are extremely anxious when it comes to climate, sustainability related topics, currently also the topic of democracy, etc. So they feel a lot of anxiety, a lot of frustration, helplessness, etc. And this particular climate emotions wheel that I have on the screen here shows like the various emotions students and others tend to feel when it comes to these topics. And you notice that the majority are very negative. This is in part a good thing because both positive and negative emotions, or that's how we refer to them, are important drivers and motivators to bring about change, as long as they're not overwhelming. So one of our jobs when we teach about sustainability, climate change, topics that can feel so complex, so challenging, is to ensure that we also pay attention to our students and our faculty and our staff and our administrators level of emotions. And in my case, I've found that helping people to identify what they are, validating them because they're legitimate emotions to legitimate threats, already tends to help students stay engaged and want to bring about change. So I'm going to switch topics a bit. I've walked you through the different competencies in addition to content that you might want to think about as you change your, reflect on your curricula. And to me, what I've walked you through are some foundations that you really have to pay attention to ensure that the students graduate such that they have the competencies in their professional lives and their personal lives to address sustainability challenges. That's sort of like, in my mind, the bare minimum. However, I suspect you, like us here at the University of Michigan, we're really interested in developing leaders. So we don't just want students to have the bare competencies. We want them to lead when it comes to their professions, their research, and or their personal lives. And one of my favorite frameworks on leadership, which has nothing to do with sustainability per se, but I think it totally holds, is this framework by Kouzes and Posner. And they suggest it's very important for us to model the way, to inspire shared vision, which relates to that future thinking competency, to challenge current processes that may never be questioned, in our case, especially related to sustainability, to enable others to act. Just because they want to act doesn't mean the systems are in place that they can. And to remember the powerful role of emotions. I was one of those people that never wanted to talk about emotions. I was raised in Austria. As a child, I was told I didn't have any emotions or to get over them. Turns out that was not the best strategy. Anyways, so we've got to get more comfortable with that and learn how to draw on emotions to achieve the goals that we want to achieve. Anyway, so that's the fundamental framework. I'll now illustrate in a few different ways. I've found some examples of different stakeholders at different universities taking on such leadership roles. And I also want to show that, to show how students can play a role, faculty can play a role, staff can play a role, and of course, importantly, administrators can play a role in ensuring that sustainability and becomes core in computing education. The reason that's so important is one statistics I came across is that data centers and AI-enabled computing alone already account for 2 to 4% of global electricity use. And the projections are that that will double within a decade. So needless to say, we need to just go not just at the basics, but we need to prepare leaders in this area. Okay, so how can students lead? I don't know what it's like in Austria, but here at my university, students really are responsible for many of the major changes at our universities. So, for example, students demanded greater focus on sustainability and climate change at university, and they're responsible for us really shifting in that way. It's not like faculty weren't interested or administrators, but if students hadn't pushed for these changes, I don't know that they would have happened. So I think students play a really critical role. And I found one example of a computing department at the University of California, Berkeley, where students really were responsible for ensuring that sustainability became integral to that computer department's work. And partly the way they did it, from my understanding, was that they have to do a capstone project where they apply what they've learned about computing to a project. And they chose to only work on projects that were sustainability and environment focused and encouraged their peers to do the same to ensure that more and more of these projects would have that angle. So that's an example of students advocating within computing education. How can instructors lead? So as we all know, faculty determine and redefine what goes in a curriculum, in a core curriculum. And I was very excited to come across this example at the Georgia Institute of Technology, which is a pretty well-known technical university in the US. And by the way, this has also been written up in an article that I cite below. You might want to check it out, where faculty came together and they decided to embed sustainability in all of their core required computer science courses. And it's treated as a core element, not just as an add-on. And they coordinated across these core courses so that students, as they go through the program, obtain greater and greater depth in terms of their knowledge about sustainability within the context of computer science. How can staff lead? So staff lead by building systems that make what we as faculty and students do with the computing, with the IT we have available to us, they make being as sustainable as possible possible. So one example I came across is at the University of Cambridge, where research, computing, and IT work together to make energy and carbon impacts of their computing resources more visible. I have to say, I couldn't find the detailed information. I would love to see it. I just know that they've worked on this. And so now faculty and students can more, better support sustainability goals because they can be more informed about their choices. Just like you, Gertie, told me, I will now be more informed about video use. So thank you for that. How can administrators lead? As a former administrator, of course, I think that role is critical. And ETH Zurich seems to be really a leader in this space, not just in Europe, but I think globally, including in their computer science and engineering space, where the administrators specifically aligned that vision, like Gertie, you now have a vision at TU Wien, for example, but a vision alone, as you mentioned, is not enough. You need to have structures, you need to have incentives. So the part of the vision was to see sustainability as part of excellence, as part of the technical excellence that students should have when they graduate, and align it with the institution's goals. The important thing, too, is resources and incentives. So we know that faculty have an incredible amount of work and pressure, and students do as well, more and more. And so asking them to do this does need incentives. In our case, or in my case, what I know is professional development becomes extremely important. So communities of practice where you facilitate interactions between folks with education background, sustainability background, computer science background, over at least a year. You give faculty some resources, some potentially, in our case, we sometimes can do buyouts, at minimum pay some kind of financial award, so that they can concentrate on learning and translating that into their teaching. Without professional development, I'm quite sure changes will remain incremental by those that, are the most passionate, not transformative. I think awards would be great. I could see, Gertie, maybe some computer companies in Austria or Google or whatever, doing some fundraising with your fundraising group and trying to create some awards for faculty, students, and staff around, having an impact on computing and sustainability. I came across one study where employers said that this was a study in the UK where they're disappointed about the fact that their computing science students don't know enough about sustainability. They want them to know more, including the business case for sustainability in computer science. And I would think they might be interested in funding an award of some kind, an endowed award. And you have great fundraising staff, so that might be a good idea, might be of interest. So with that, I'm done a little bit early than the 40 minutes marker. I was so worried about hitting the 40 minutes marker, maybe went a little bit too fast. But I want to thank you for attention to taking you through a whole bunch of information very fast. And I'm happy to take your questions, or we could also talk about the questions on the slide. I'd love to hear what you may already be doing, which of these questions you find of interest. And yeah, that's it. Thank you very much.
Thank you. I was just, so thank you, Michaela. Great.
Oh, thank you.
So, because just to the last point, you were mentioning awards, and therefore I was looking up, I think there is it's one.
There
Yeah, there
might
should
be
be much
something.
more. There is an award from the Austrian Academy of Sciences.
Oh,
It is financed by, in fact, a small company. It's called Teams, like a team, but the company
oh
is called
yes.
Teams. And it is in the area of critical infrastructures and
Mm,
has a link to, critical infrastructures also have a link to sustainability
hmm.
on a perhaps
Right.
broader scale also. This,
Hmm.
and by chance I came across this because a former PhD student of mine is working for Teams, and I thought, wow, it's a great idea that this small company, yeah,
Yeah.
and this is exactly what you were saying now, no? That in fact, yeah, it would be perhaps, but I don't say easy, but it would be a good
It
idea
should.
to approach
Yeah.
industry and say, wouldn't you like to fund like
Yeah.
best master thesis in sustainability in
Exactly.
computer science, something like
Yeah.
that. Yeah,
There you go. And then they have somebody they might want to hire right then and there.
yeah, exactly. This is always they are not industry is not altruistic, but it's fine. It's totally
Right.
okay.
Yeah. It works.
Um, Also, another thing, also, perhaps if
Yeah.
students have questions, then they can also write it in chat and so on. But one other thing, when you were saying, this, also what I really liked is how the students, the scientists, the professionals, the administration have they not only have a vote, they have they have a power to change something.
Yes.
When you were mentioning this, that sustainability issue should be embedded in all perhaps courses, or at least
Yes.
in some courses. Something similar happens with this discussion of ethics in computer science.
Makes
There's
sense.
embedded ethics with
Okay.
CS written in capital
Okay.
letters,
Mm.
embedded ethics in computer science. I think it started out, no, Stanford, in one of
Mm.
these Ivy League
Yes.
universities. And I think something similar should also, we should kind of rethink. I know that
Yes.
my colleagues are not, at least not a majority of them is
Mhm.
kind of as emotionally involved as I am.
Yeah.
But I guess we have to go into this direction.
You
I'm totally
you
sure.
you have to keep talking.
Yeah, exactly. And last but not least, I like this idea of the living lab.
Yeah.
Um, I mean, we have, just to mention, it's very, very, very small, but it's starting point. There is an applied research project um, building the digital twin of a green facade of one of our computer science buildings. In
Oh,
other words, they have now really managed to do little plants in front of the facade. So
okay.
they even did it just finished in November, and they are still alive. So I have no idea how the little green plants survive minus 10 degrees. What we have now,
Okay.
but they do. And it's an applied research project in the sense that there are sensors everywhere, and they are building a digital twin of this green facade to find out more or less in real time where to put more water or more heat or more whatever. Yeah?
Mm-hmm. Mm-hmm.
So, and there are student projects behind this. So
Yeah.
this is a kind of a living lab to a certain extent.
That's exactly right. So I just shared online something I came across from students at the University of Michigan. These were not computing students. These
Okay.
are sustainability students who
Yeah.
looked at AI usage at U of M and developed some recommendations. It's along the lines of what you were saying. And, you know,
Great. Yeah.
when you and I talked, you know, there's this debate in education, in my field of education on what's best, incorporating sustainability into existing courses or having sustainability focused courses related to the discipline. And I don't, you know, it's as with anything, I don't think it's an either or. I think it is a both. You need both because first of all, the sustainability focused courses are only going to be taken by the students that are most interested unless you require them. And that's not ideal for a variety of reasons. So the embedding reaches more students and is important to help them show the application, the connection of sustainability to what they're studying. And a single course where you cover it's never going to do that. It's insufficient. It also doesn't convey the norm. You know, it's like, oh yeah, you know, for those of you interested, this is good, but the rest of us, we really don't care. And so I think encouraging faculty to develop at least one module where they incorporate the topic is important. And as administrators in the US, we can do that in the sense of we can make it part of annual performance reviews. We can make it part of their merit raises. I've not yet seen it in promotion and tenure, although we're talking about it all the time. But I think that will take a global transformation in tenure processes. But I don't know what I know in Austria it's more complicated because you've got a union and all that. But I do think there's a lot to be said for modeling and highlighting people who do it well and rewarding them in other ways, such as these awards, visibility, you know, publishing articles about their work. You know, we faculty all are interested in similar things. And so you can still do a lot to highlight the people that you want to highlight because you want that work to be of value. You know, thinking your rector, shaking hands and taking a picture of the top people, you know, it's simple things, but people, we value those in academia. So, so anyways, I do also believe in, as you and I discussed in the past, I created a model at my school where we, well, first of all, our students don't complete individual theses unless they elect to. The default is working on projects, interdisciplinary projects with clients that are outside. And there's certain criteria that those projects have to fulfill, which is their interdisciplinarity. So if you had if you could develop a course or opportunities for students to work in teams on computer science problems that also had a sustainability element, you know, I think that would be of great interest. Although I also know, of course, how hard it is to already teach the courses that you must teach as part of your program. You know, I think one of the challenges of your program, just like the medical field is similar in the sense that they have so many requirements. There's so much that has to be taught. It's really, you know, people really struggle. But I think there you just have to say, well, if we don't start doing this, you know, we don't have to worry about anything because our world will fall apart. You know, I alluded, you had Stagel talk about planetary boundaries and so on. So, so if we don't change, we don't have to worry about any curriculum or research in the future. Yeah.
Like the Kipppunkte, I think, I don't know.
Yeah, tipping points.
Tipping points, thank you. Yeah. So they are here.
Yeah.
There is one very practical kind of part you have mentioned, and where I don't know why there is not more going on in Austria or at our university, is this measuring, yeah, what you also mentioned. You have to show or you have to
Assessment.
provide kind of alternatives. If you do A, then you consume as much CO2 or water. And
Oh,
if
yeah.
you do B, you
Right.
yeah. But,
Trade-offs.
in trade on every, when you buy some yogurt, you can really see as many percent of
Yes.
all the ingredients and many calories and so on. Yeah? So kilojoule. Yeah, so
Yeah.
you have everything. Something,
Right.
I know this is difficult, but we should start that we know, okay, how
Yes.
much CO2 has been spent when they have started now. I think that, in the supply chain, they have to trace back where the materials and raw materials and
Yes.
so on is coming from, with all
Right.
the difficulty. But something similar we would need on the consumption of CO2, water, as all
Yes.
the resources.
Yes. No, the whole, I mean, I'm glad you said two things. You said, in my mind, you're talking about life cycle analysis,
Yeah,
not
right.
just
Thank you.
usage, but, not just, obviously me using AI today has a certain impact on energy use and
Yeah.
water use and land use and all that, but and has certain CO2 emissions. But even before that, I've learned that the big energy investment is in training these AI tools. So, and then I've learned that there are different ways to train that might save. And then I've learned that we're using these large language models for problems where we don't need them. We could actually do smaller models. And and then frankly, do I need the level of accuracy? I find so I've learned that there's a lot of AI focused on ever increasing accuracy, but ever increasing accuracy has a disproportionate impact on energy use. I learned a lot in preparing for this talk. And do we really need that level of accuracy? I would say when you do brain surgery, yes, please. But if you're doing some other things where you have a confidence interval in which you can remain, then why? So I do think there's a lot of work. I tried to also highlight, we have one researcher at U of M that studies some of that, who told me a little bit more about the complexity of doing what you're saying, Gatti. But that's what I would like as a user. I would like to know how much energy did my search just use, and how could I do it using less, and I'm frustrated by Google, for example, with Gemini. I can't turn off
Yeah,
Gemini. I
exactly.
don't want Gemini. Let me just do a simple, they said Google searches use like 10, no, AI uses 10 searches, use 10 times more energy than a Google search. Well, but I can't search Google
Yeah.
without the AI. It should be able to turn it off. So I do have to say there's tremendous opportunity. In the chat, I put a link to a TED Talk
Yeah.
where a woman claims she has like the solution to this, but I talked with some of our experts and they say it's so complex at this point. Anybody who claims they have a solution is probably making a lot of
Selling.
assumptions.
Yeah. Yeah, but on the other hand, I think we have to
Yeah,
start. Yeah.
I
So
agree.
that, yeah.
Yes,
And if it's just to say, I don't know, we haven't fully put on all our heating, so therefore we could save, I don't know, 10% today. It's awareness building. It's really the whole
yes,
thing at the
that's right.
beginning. And you said communication. Yes, it's about
Yes.
communication and awareness building. And that's why we are doing this public lecture series, because otherwise you could
Yes,
say, who cares? Yeah,
exactly. I think it's
we have
fabulous.
to.
And I think, you've got to remember you have people who would be big supporters. So I'm on Boku's region board,
Okay.
as you might, not region board. I'm on
Universitätsrat.
I'm at the Unirat, and
Ja.
I work with
Die
on their
Aufsichtsbehörde oder der Aufsichtsrat der Universität.
ja,
Ja.
genau. Und ich arbeite dort mit Katharina Rogenhofer.
In
Der
English,
Name
in
sagt,
English, ja.
I'm working with Katharina Rogenhofer,
Ja.
who's also in the Unirat, and she is, she said the following to me, because I asked her if there's already a group in Austria that's working on this topic in a sort of NGO sense, nonprofit sense. And she said she doesn't know of anybody herself, but she said this in German. Netze effizienter zu machen, ist jetzt gerade ein großes Thema. Und da wird es tolle IT-Menschen brauchen. Sonst suchen sicher auch immer die Wiener Stadtwerke immer wieder tolle Menschen. Also, so she was like, she recognized it as she's a leader in climate change in Austria. I think she started the Volksbegehren in Austria.
Okay.
The Klimavolksbegehren. She was behind that. So remember that you have with Boku, I think Boku is now part of the technical university group.
Yes, exactly.
And I think reaching out to them and maybe finding some ways for faculty. I mean, you obviously have plenty of faculty yourself who know plenty about sustainability, including in this lecture series. But I think developing some partnerships around that
would make a lot of
would be great. And I bet that there are people in the NGO world and in the corporate world who would be willing to support these initiatives, let alone government. And with the budget cuts that are coming, that I understand, which sound pretty serious, it might be opportunities for something new that I didn't come across too many programs that focus on both computer science and sustainability.
Totally right. There is some from the Applied Research Agency, FFG. They have this green AI or green energy. Also, they have some funding scheme where, when you look closely, there is computer science involved.
Okay.
Also, in the green energy, of course, we are talking about smart grids. We are talking about personalization, about like precision energy, like precision medicine, so to speak.
Yes.
But they are not kind of on the headline level, like computer science and sustainability. I think you would have to look for a long time. You will find nothing. So but it is embedded,
it's embedded, but it's not highlighted. So it could be a competitive advantage, especially if programs in English, and especially if it's like a partnership with. I know that I believe when I looked, WU, so your business university, had some partnerships with maybe TU, I don't forget, where they have some joint programs. If you could develop a joint program between Boku and TU Wien in this space, maybe. I mean, you have plenty enough for yourself. But
it is a good hint, especially since they are now in the Technical University Austria.
Exactly, makes
framework, so it is another, as you said, resources are not becoming more but less, so it makes a lot of sense to show, to share resources and to show that we work together, because then in a joint fashion, I think we have now, the students didn't ask as much, but I guess they have got more ideas now in the way how we are discussing this.
Yes, and we have 5 more minutes, so if a student wants to speak up or throw something in chat, I'm happy to answer any questions. Don't be shy.
What I also have learned is really this climate emotions wheel. I have to look at this more closely, because again, it is the topic to a certain extent is it's an emotional topic because it is used like in the political arena to to divide friends and enemies.
Yeah, to minimize. Yeah.
Yeah, but at the very end, as you were saying, there are these planetary boundaries. We
Yeah.
have to think of how to, yeah,
So actually in
how to
summer,
change.
I've decided to learn about these emotions, and it's a very personal story because I developed as a result of menopause, which nobody talks about, of course, more so now than in the past, but I developed severe anxiety and depression. It was about 7 or 8 years ago. It's part of that transition. And I didn't know what was happening. And thankfully, got mental health support, and finally some doctors smartened up and told me what was going on. And I learned just how powerful anxiety is. Meaning, I always was under the impression, why can't you control your thinking? Like,
We are
well,
technicians. We can,
yeah,
and scientists.
that's
We can
right. That's right.
control. Oh,
Well, I am very glad I learned what that's really like, and it was the most horrible thing. I wouldn't wish it on anybody, but I'm really glad I learned about it, and it made me think if emotions are, that powerful in our personal lives, they must play an important role within addressing sustainability challenges. And so that's something I've been focusing on. So when I come in summer, that would be an easy one for me to address. Now,
okay.
what I'd be curious about from the students here, and maybe you could return a little bit of a favor, and I'm going to ask you what's one word that comes to mind when you think of climate change. Would you put it in the chat, everybody? What's one word when you think of climate change? And you could put it in German or in English, I don't care. One word, somebody. Polar bear, yeah. Global warming, hot, great. Keep it coming. Urgency, great. Future, overhyped. Oh, interesting. Yeah, yeah, yeah. Helpless, there we go. Yeah. One word. Collaboration, excellent. Yeah. Scared, yeah. Thank you. Frustration, totally get it. We get a lot of frustration because in our student body, because they're just so mad. Because, we've known about this challenge since the 1800s. And politicians and corporations, inevitable. See, this is this future vision challenge. Thank you so much, all of you, for being so honest about what comes to your mind. We really appreciate that. So anyways,
Reversible, yeah.
I think
Question.
is reversible. Yeah. Well, not at this point. Will take a long time. Hundreds of years already. Yeah.
Just
So,
I think it was as a great thank you that you asked. Yeah, I would, yeah. I
so
haven't asked our students about this, but I think this is really a very, yeah, I should say honest and also very, yeah, deeply involved feedback, no?
yeah,
It's
it
also, this lecture series is really totally elective. Also, no,
mhm,
nobody has to
yeah,
take it. So,
right.
just people who say, okay, um, perhaps I hear something about how to change. Yeah, will attend
Mhm,
this. So I think this is very interesting.
yeah.
Yeah.
So I do one of the things that I try to maybe say, not in the best way possible, is, for those of you who want to get involved and it will help make you feel like you can make a big of a difference, is the best place to do it at your university. And Getty is a big supporter and can connect you with people at the university who make decisions, who might want some input, and you show your leadership, which is good in a very competitive job market, to give examples. And at your university, you can really make a difference, especially when you work with others. And there are student groups, I'm sure, at your university that are interested in sustainability or others. There are nonprofit organizations. At minimum, I would think the Sierra Club would have a unit in Austria, and Sierra Club is very policy active with climate change. And I do want to also recognize the one person who said overhyped, that, for example, I'm going to give another example. I'm much more concerned about in the immediate about water shortages. Now, Austria is very blessed. Michigan is even more blessed with our Great Lakes. But if you're concerned about the rest of the world, water shortages, they're already huge. They're already causing a lot of conflict, even more so than climate. I think the reason we talk about climate is because climate may not be the worst thing right now, but climate makes everything worse. So the water shortage would have been there anyways, but because of climate change, it already is worse and will get way worse. In the US, our energy infrastructure, the grid is atrocious, just like everything else. The country hasn't invested in infrastructure or much of anything else for a long time, which is now also showing up in this mega movement. It's all connected. Anyways, and the infrastructure that we have is already old, is already crumbling. And climate change is making it worse again, because, for example, here they have a lot of above ground electricity. So when you have more storms and more severe storms, those are more likely to break. Flooding impacts the infrastructure. So I think that's why so many of us are interested in climate change, is not because we don't see it as the most immediate, most severe issue, but it just makes everything worse. Migration. We're getting more migration, which we would be getting anyways, but we're getting it even more so because of the impacts of climate change, extreme heat, lack of, reduced water, increased conflict. So when it gets hotter, you get more violence. And so there was already plenty of violence before. Now you're getting even more violence. So you get more migration. So I appreciate that. Thank you so much for saying the overhyped, and I'm not disagreeing in some ways. Anyways.
Yeah.
Okay. We're over.
Michaela, it was absolutely great to have your presentation. Thank you very much. It is really a lot of, ideas to think further and to perhaps start changing here and there. Thank you also for kind of pushing our students, our participants, that they have a voice and that they can do something.
Yes.
And they should start in their home university.
Yes.
So, and really, please leave a note when you are coming in summer, whatever
Well,
summer means. And I
Okay.
think we should continue the discussion.
Gerti, can I talk to you for just a minute after we finish here? And then thanks everybody for coming, and I appreciate your attention, and I appreciate your sharing of where you're at with regards to climate change. Thank you.